Hello everyone, my name is Drew Thompson and today we're going to be discussing a research article that covers dose-related effects of vitamin D on immune responses in patients with clinically isolated syndrome and healthy control participants. To get us started, we're going to be going over some basic article information. So it was published on the 27th of August in 2013 by the Biomed Central, a branch of Springer Nature. And in regard to the researchers that participated on this article, we have several that are coming from Ireland and various schools within them. They also have their own specialties. And if you'd like more information, it'll be on this slide here. So vitamin D has been shown over time to have great immunological effects on our body regarding sicknesses and diseases. However, more specifically, we're going to be analyzing the increasing evidence linking vitamin D deficiency to both susceptibility and severity of multiple sclerosis. Well, what is multiple sclerosis? In case you don't know, it's a disease that deteriorates the protective covering of nerves, resulting in the disruption of communication between the brain and body, so heavily affecting our central nervous system. And on the right here, we have an image of what a healthy neuron looks like versus one that is affected by this multiple sclerosis disease. The aims of this study are to examine the immunological effects of vitamin D in both healthy individuals and clinically isolated syndrome patients. And in this latter group, we're going to be looking about how this disease progresses with these doses of vitamin D. And we're going to be analyzing that through MRI and clinical measures. For the methods of this study and the design in particular, it's going to be a single-centered, double-blind, randomized, placebo-controlled trial. And as mentioned earlier, we're going to be analyzing the immunological effects of these two doses over the course of 24 weeks in both of our two different groups there. And rather than a white powder-based pill, it's going to be an oil supplement at a dose of 5,000 international units or 10,000 international units. So the primary endpoint, we want to analyze T cells and how those are going to be altered based on this supplementation over time, and also analyze these cytokine responses in the peripheral blood of mononuclear cells. The secondary endpoint is going to be determine how the difference in dosage is going to affect our CIS patients. Who are the participants in this study? Well, we have our two groups, with the first one being 45 who have the clinically isolated syndrome, aka multiple sclerosis, and they're going between the ages of 18 and 55 with symptoms that have occurred in the past 3 months. They're going to need to have 2 or more asymptomatic T2 lesions on the MRI brain that show demyelation, and they're not going to have been able to be taking DMT or any other steroid treatment. The other group is going to be our 39 healthy control participants, ages 20 to 40 years old, with a ratio of 2 to 1 females to males. And why do we have this ratio? Well, as shown in other studies and on a graph here on the right, women are almost 2 times more likely to be diagnosed with multiple sclerosis. The methods and measurements that will be used to conduct this experiment will be changes to medical history, and that will be assessed at the beginning of each one of our neurological and physical examinations. There'll be blood biochemistry that will be assessed at each visit, and then the main things that they're going to be analyzing will be the vitamin D levels and parathormone levels that will be analyzed at the baseline of every 4-week period. The immunological analysis at baseline and at 16 and 24 will also occur to measure those T cells we mentioned earlier, and the MRI scanning will be conducted at baseline and 24 weeks to assess the different types of lesions that could occur. Well, the results are not quite what they anticipated. If we look here, we see that our CIS group, meaning the placebo, the 5,000 international units, and the 10,000 international unit treatment arms, displayed mean changes in serum levels from baseline to 24 weeks, starting with 18 nanomoles per liter to 76 nanomoles per liter and 155 nanomoles per liter. However, this also did occur in our HCP group with increasing levels in those nanomoles per liter, starting at 2, then to 92 nanomoles per liter, and then to 136 nanomoles per liter. Where things get challenging, though, is that we didn't see a ton of significant data regarding our immunological effects. There was no significant reduction in the number of T cells subset in response to the supplementation. The MRI results also showed that there was not a difference between the number of new lesions or the proportion of participants with new activity on the follow-up MRIs. Higher levels of disease freedom, 67 versus 50%, was seen in those with serum levels greater than 100 nanomoles per liter. However, this did not prove to be statistically significant, meaning that it's not really a valid conclusion for this study. If you're a little confused on what all that information could mean, this slide might help summarize it for you. Vitamin D supplementation of doses up to 10,000 international units daily is safe and tolerable for both our HCP and CIS participants. However, the main primary endpoint of this study did not prove to be significant. The high doses did not alter frequency of T cells, meaning that this trial ultimately failed to meet that primary goal. The hypothesized therapeutic effects in CIS or multiple sclerosis patients may require longer periods of administration, meaning that there will have to be another study conducted over a longer period of time to draw any significant conclusions. I want to thank you all today for attending and being a part of this presentation with me, and I hope you enjoyed and learned some new information. Thank you.